This is the key for the Unit 16 review. So a lot of these, again, are just questions that you can kind of read through for yourself, but make sure that you know these things. So definition of an acid, you can consider it either a proton donor or an electron acceptor. Bases, proton acceptors, or electron donors. There are other definitions, but those are the two main ones that we're going to focus on for this class. Properties of the acids and bases. Again, there are more of them than these, like acids are corrosive, but these are the 6 that I want you to be responsible for knowing, so I'll ask you about those sorts of things. pH and pOH. So first of all, you have to understand that P is just an operator, which means negative log. And so if we say pH, we mean negative log of the concentration of H. pOH, negative log of the concentration of OH. And because of this equilibrium that exists with water, pH plus pOH, if we're talking about a solution that is in water, it's always going to be 14 when you add them together. So that's a nice relationship that they have. And you'll use this equation quite a lot, actually. So the connection between H plus and H3O plus. They're pretty much synonymous for the purposes of this unit. Basically what an H plus is a proton, but when you put it in water, it actually attaches itself to the water molecule and it becomes H3O plus. And so if you have H pluses in water, they are H3O pluses. So in any of the equations or anytime when we're talking about H plus or H3O plus, those two are sort of interchangeable. All right, here talking about the pH and how much it changes. So this is talking about the fact that pH is a logarithmic scale on number 5. So we're changing by 6 here. So if you've got a pH difference of 6, that means that we're going to have 6 powers of 10 in there, or 6 multiples of 10. And so if you take 10 and multiply it by itself 6 times, you get 1,000,000. And that's how this always works. So you just take however many the difference is, and you take 10 to that power, and that's how many times it is. It's because it's on this logarithmic scale. So every difference of 1 is a magnitude of 10 difference between the two. These are the 6 equations that you need to know. Oh, sorry, well, actually you don't need to know them. I'll give them to you on the test, but you need to know how to use them on this. So familiarize yourself with them, know how to do these different problems, and I think that you should be pretty good to go. For this table, it actually takes a bit of calculation. So the first thing that we're going to do, if we want to calculate pH, you need to take the negative log of that H3O plus. So put in negative log of 2.4 times 10 to the negative 5th. That has 2 sig figs. So our pH here would be 4.62. Concentration of OH, there are a couple ways that you can get this. I think the easiest way is probably to find the pOH next. Just take 14 minus that 4.62 because pH and pOH add together to be 14. And you get 9.38. Concentration of OH, if you take 10 to the negative 9.38, that will give you concentration of OH. So that's 4.2 times 10 to the negative 10th. All right. Then this one, is it acidic or basic? Well, look at the pH. You see that the pH is less than 7. That makes this one acidic. For the second row here, I've given you the concentration of OH. If you take the negative log of that concentration, you can get the pOH, that is 1.13, which means if we take 14 minus that, we'll get the pH, that's 12.87. And then 10 to the negative 12.87 gives you the H3O concentration, that is 1.3 times 10 to the negative 13th molar. All right, next one. Let's go to the end column here, actually. So the pH is 12.87. That's much more than 7. So this one is basic, and actually pretty strongly basic. So on row 3 here, we're given 3.56 for the pOH. To get concentration of OH minus, you take 10 to the negative 3.56, which if you calculate that, you should get 2.8 times 10 to the negative 4 molar. For pH, we take 14 minus 3.56. You get 10.44. All right, and then 10 to the negative 10.44 to get H3O plus gives you 3.6 times 10 to the negative 11th molar. Last column here, pH is 10.44, that's more than 7, so this one is basic. All right, last row, we're given pH. You can calculate pOH from this. 14 minus 12.25 gives you 1.75 for the pOH. And then we just take 10 to the negative power of these to get their different concentration parts. So H3O, that's 10 to the negative 12.25. For that, you should get 5.6 times 10 to the negative 13. For a concentration of OH, that's 10 to the negative 1.75. You should get 0.018 molar. Alternatively, you could have called this 1.8 times 10 to the negative 2 molar. It would have been the same thing. pH 12.25, that is also basic. Looking back here at this table, I notice that I wrote -3 as the exponents on the 10 for this, and it should say -13. So make sure that on your paper that that is corrected. Those should have exponents of -13 and not 3. Question number 8. I think actually if you handle that table, these other 3 questions are not too bad. Some of them are two-parters, but you know, it's not too difficult. So this first one, it gives you molar solution of NaOH, and it says it dissociates completely. You have to identify if it's talking about NaOH. We have a base here, and all of that 0.0105 molar is going to be in OH concentration. So we know concentration of OH minus equals 0.0105 molar. Then from that, we can find the pOH. All you have to do is say pOH equals the negative log of equals negative log of this concentration here, 0.0105, and you get that pOH is equal to 1.979. All right, and then take 14 minus that, and you get pH. So pH is going to equal 12.021. And then if you look at the pH there, that should indicate to you that this is a basic solution. All right, for number 9, I've given you the concentration of hydroxide. I'm asking you for the concentration of H+. So on this one, we're going to use the equation H plus times OH minus concentration equals 10 to the negative 14. I actually really don't like this equation very much because lots of people mess up when they're putting it in their calculator. But in this case, this is the case where we want to use it because it makes this a one-step problem. All you have to do here is take 10 to the negative 14 and divide it by that concentration of OH, and we get the concentration of H plus. So in this case, concentration of H plus equals 10 to the negative 14 divided by 9.87 times 10 to the negative 9. All right, and try and use your EE key there on the bottom in the denominator, or use parentheses to keep it together, one of those two. And you get 1.01 times 10 to the negative 6th molar for the concentration. For this last problem, it gives you the pH. It asks you for the concentration of OH minus. You have a couple paths for this. My recommendation is that you go from you go from pH to pOH and then go to the concentration of OH minus. I think that that makes the most sense. So if pH equals 9.95, pOH is going to equal 14 minus 9.95, which equals 4.05. And then if you plug this in, you get concentration of OH minus equals 10 to the negative 4.05, which is 8.9 times 10 to the 5th. so this -5th molar. If you have any questions on any of those, come see me. Otherwise, also go back and look through your worksheets for this unit. Make sure you understand all of those, and I think you should be good to go.